Number 11. Number 11 is x to the 6th plus y to the 6th. We got to write it as a cube, right? And so what we're going to do is we're going to say, what's the cube root of x to the 6th? It's x squared, because x squared times x squared times x squared makes x to the 6th. So we're going to write x squared cubed. And what's the square root of y to the 6th? Y squared. So we're going to write y squared to the 3rd power. All right? Then, everywhere there's an a, we're going to put an x squared. Everywhere there's a b in the cube formula, we're going to put, wherever there's a b, we're going to put a y squared. Now, the formula for this is, what is it? A plus b times a squared minus ab plus b squared. Did I get the right formula, you guys? Yeah. Okay. All right. So that's what they look like. Now, so wherever there's an a, I'm going to put an x squared in there. So I'm going to go x squared. And wherever there's a b, I'm going to put a y squared. So first part of my problem is x squared plus y squared. Got it? Now, there's an a, and it's being squared. There's an a, and I'm going to put an x squared in place of that a. That would be x to the 4th power. I just wrote it out like that so you guys can see it. And then I have an x squared times a y squared right here. And then right here I have a b squared. Well, that's a y squared for the b, and then squared. Okay, so if I was to write these out, what would I write x squared to? X to the 4th. And then x squared, y squared. And then y to the what? 4th. And there you go. Well, let me tell you how you get it, you guys. I know how it is learning new math. Okay, I've done a lot. Last night, I had to learn new math. My son is taking calculus. And I had to study. Actually, I learned it about 20 years ago, but I couldn't remember it. And so I had to read his whole chapter in his book. His whole lesson, I mean. I had to read his whole lesson to understand how to do the problem. And it was like completely new to me. And I had to do it over and over and over and think about it until I finally got it. And that's how your brain works. Your brain doesn't just pick up on things. You know, now that I know something, it's like it's so easy to me, and sometimes I start thinking, why can't these guys get it? Okay? But then I got to remember, when you're learning new things, it takes a little while, and you have to think about it, think about it more, think about it more, think about it more, and you finally your brain starts making sense of it. The problem with some of you is you're not taking enough time to think about it. You're not spending enough time on it right here. If you guys just spent the time I did in class and thought about it, you'd improve tons. But when you don't spend time working on it, you don't learn. Did you guys know that something that you have thought about a lot, did you know that your subconscious will work on it while you're sleeping? Did you know that? That's the power of the brain. It's really cool. If you spend a lot of time thinking about something, and you're thinking, your brain will work on it while you're asleep. Some of the greatest inventions have been people who have been working on something for days at a time, or months at a time, or years at a time, and they work on it every day, and all of a sudden one day the light bulb comes on. But they usually wake up in the night knowing how to do it. Their brain has finally made all the connections to figure out how to do it. And I'm talking right now. If you guys want to say something, raise your hand, and then I'll call on you. Okay? But your brain really works that way, you guys. So you got to think about something a lot, and then you'll start getting it. You guys, I promise you, this math is not impossible for you guys to do. I promise. There is not a single person in here that this is impossible to do. Some of you have to spend more time than others doing it. Okay? But it's not impossible for you to do. Every one of you are capable of doing this. You have to just spend enough time thinking about it, and you can get it. Okay? That is true of everybody in here. Not a single one of you can't learn this. All of you can do it. Okay? And you have to spend enough time thinking about it, and you'll get it. And the more time you spend thinking about math, the easier all math becomes to do. becomes. And you can do it all better. Okay? So I'm just telling you, if you want to learn this stuff, and you want to do well in school, you want to go to college, you want to learn some things, and you want to get a good job someday, spend the time thinking about the things that are going to help you get where you want to get. Okay? It might not be math for some of you. Okay? Although I think math would benefit just about every career because it develops your left brain thinking.
I mean, I want to own business, but the problem is I can't do math, so I have another guy do it for me.
Yeah, but you know what? I've started business before, and when you're first starting a business, you need to sometimes, because you don't have the funds to pay someone else, you need to do it yourself. And besides that, sometimes a lot of business owners do what you just said right there, and they don't know how to do any math, and they let someone else do it, and that person cheats them because, okay? So, okay, well, you better start looking for one right now. Okay. All right. Okay. All right. So you guys got to spend enough time thinking about it. All right. Okay, you guys, lesson domain 3, page 6, and your objectives. We're going to learn how quadratic functions in factored form and write quadratic functions in vertex form. Guess what? Learned both these things before. I don't know why they have us teaching it again. I think it's to kind of review and make sure you understood time. Gives you a second chance. So you guys have all learned this before, except for maybe if you checked in recently. Okay, so you should have learned this already. But we're going to relearn it. Okay. So we're going to write quadratic functions in factored form. Okay. So let me give you an example. X squared plus 16x plus 63. Now, this is a quadratic expression. It's not a quadratic equation. What's the difference between a quadratic expression and a quadratic equation? An equation has an equal sign. That's exactly right. I don't know why they didn't teach us using quadratic equations instead of quadratic expressions, but this is the way they want me to do it, so I'm going to do it this way. Okay? Now, we were just doing this a few minutes ago with those quadratic lookalikes. Yes, Christian? Yeah, what two numbers can you times together to get 63 and add together and get 16? Okay, 7 and 9. Yeah. I wanted to show you guys. 9 is 63. Is 7 plus 9 16? So 7 times 9 is 63. 7 plus 9 is 16. So those are my two numbers. Okay, I want everybody, and so now you're going to write it like this. X plus 7 times x plus 9. Once again, does it matter which order they're in? Well, let me explain it this way. I want the two numbers when I times them together to be a positive 63, right? And when I add them together, I want them to be a positive 16. Well, the only way you're going to get a positive number right here when you times two numbers together is if they're both positive or both negative, right? Well, a positive 7 times a positive 9 is a positive 63, and a positive 7 plus a positive 9 will add up to 16. If they were both negative, negative 7 and negative 9, they would add up to a negative 16. And that would be a minus sign right there. So since I knew that was plus, I knew they had to both be positive. Does that make sense? Okay. So that's all you had to do is factor it. Can you do that? That's it? Yeah. Yeah. Let me give you another one. Let's say I have x squared minus 7x minus 30. Now, I'm not going to give you this one. I don't just say everybody to do this. I want you to factor it. I'm going to give you a minute to do it. Find two numbers you can times together and get negative 30, add together and get negative 7. Afterwards, I want you to share it with your shoulder partner. If you don't have a shoulder partner, that's the person at the same table with you, then check with the people in your group. Okay? Okay, so the answer to this is x minus 10 times x plus 3. Think you can handle that? Okay, let's try another one. Let's try this one. X squared plus 6x minus 55. This one should be kind of almost be a giveaway right here. Okay, so I found all the numbers and times together and get 2. So give me some numbers. 1 times 20. What else? 2 times 10. 4 times 5. Okay, is that it? I could do the negatives too. I could go negative 1 and negative 20, negative 2, negative 10, negative 4, negative 5. However, when these are both positive, you don't need to do that. Okay? All right. Now, I have got to try and match these up now. I've got to find which number over here matches up with that number there, so when I multiply them together and add them, I get 13. For example, let's say I tried 2 times 5 and 1 times 4. Okay? Well, what's 2 times 5, everybody? 10. And what's 1 times 4? And if I add those together, what do I get? I get 14. And what do I want my 13? So that's not it, right? Okay, let's try another one. Okay? I'm going to erase these. Let's try, let's say I times 2 times 4, and I times 1 times 5. Let's try it that way. 2 times 4 is what, everybody? 8. 1 times 5 is what, everybody? If I add those together, what do I get? Well, guess what? That's it. I didn't even have to try the 2 and 10 and the 1 and 20, right? Didn't even have to try those. Okay? So I know my two numbers are 1 and 2 and 4 and 5. Okay? Got that? So I know those are pairs. Now the question is, how do I place them in the binomials? Okay? I can either do my x's first or my y's. Do I want to go 1x and 2x first? 1x, 2x? Let's do it that way. Now the question is, how do I know which way I put 4 and 5? It does matter this time because one of them has to be in the same one as the 2 and one of them isn't supposed to be in there. And in this case, if you noticed, what did I times the 2 by over here? I times it by the 4 when I got my number 13 in the middle, right? So I times 2 times 4. So I know if I put 4 in the same thing as 2, I'll never times them together. And I'm supposed to times them together, right? So where does it have to go? On the other one. It has to go in this one. And same with 5. 1 times 5, I have times together. Well, this is 1x. I can't put it in the same one. I have to put it in the opposite one. So it has to go over here. And there's my answer. Yeah, you can write 2x plus 5 and x plus 4. You can write it like this. You guys, every time. You guys, let me ask you this. That's the same answer, isn't it? Same. Let me ask you guys this. I'm going to ask you guys a really hard question. Ready? What is 2 times 3? 6. Told you it was going to be hard. I'm going to ask you another really hard question. Ready? Is 3 times 2? 6. Close. Okay. Now, if I switched the numbers around when I multiply them, did it make a difference? No. We call that the commutative property of multiplication. With numbers, it doesn't matter which way you multiply them, you're going to get the same answer. Same with these factors. That's why, Chase, you've been asking me, does it matter if we turn them around every time? It doesn't. Because you're going to get the same answer either way. Okay? Yeah, if I had an x minus 5 and an x plus 4, it wouldn't matter if I went x plus 4 first and x minus 5. But the negative has to go with the 5 and the positive with the 4. Okay? So that does matter. Okay? All right. Let's try another one like that, should we? Or you guys kind of get it. I'm gonna leave it at that. See if you guys can get one. I got to do one more problem. The other problem I'm going to do is, okay, the first objective right here. Write quadratic functions in factor form. I'm going to teach you guys how to write quadratic functions in vertex form. A review. Okay, I'm going to make one up. X squared plus 8x plus 10. Okay? And I want to write this in vertex form. Why would I want to write it in vertex form, everybody? So I can find the vertex, okay? Do you remember we used a process called completing the square? Remember this? Completing the square. We did this in the first quarter. So if you don't remember it, hopefully this will jog your memory. I have to make a perfect square trinomial. Remember we just learned about perfect square trinomials? When you factor them, the factors are the same. Well, guess what? Is 10 a perfect square? 10 is not a perfect square. So this is not a perfect square trinomial. So what we're going to do is we're going to complete it to make it a perfect square. And how we're going to do that is we are going to group the first two terms together with a space there. And we're going to put the 10 on the outside since it's not a perfect square. Okay? Now, to get a perfect square, do you guys remember what I do to this number right here? What do I do to it? I take half of it. What's half of 8, everybody? 4. And then I square it. Good. Some of you guys remember this. What's 4 squared? No, 4 squared is not 8. 16. That's 4 plus 4 is 8. We want 4 times 4, which is 16. Now, I can't just go around adding a number without... Just think about this. If this was an equation, and that's what it is technically, I can't do it without unbalancing it. If I add 16, I got to do what? Minus 16. Now, I'll either need to add 16 to both sides, or I have to go 16 minus 16 on one side. What's 16 minus 16, everybody? 0. So if I add 16 and subtract 16, is it the same thing? Yeah. The only difference now is I've changed what it looks like. It's the same value. I just changed what it looks like. Okay. So now, guess what this is right here? This is a perfect square trinomial. Get factors. What two numbers can I times together and get 16 and add together and get 8? In fact, 4 times 4 is 16, and 4 plus 4 is 8. Does everybody got that? So this is going to be x plus 4 times x plus 4. Do you remember that? And what's 10 minus 10 out here? It's going to be a negative 6. Okay? So the perfect square trinomial factored into two factors were exactly the same. Remember we just learned that a couple of days ago? And now, what's the short way of writing x plus 4 times x plus 4? X plus 4 in parentheses squared minus 6. And now we're in vertex form. Okay, Nicole, where's the vertex? Sarah, where's the vertex? No. No. Negative 4 and negative 6. Remember, the one inside the parentheses is always opposite sign. Since that's a plus 4, it's a negative 4. And this one out here is the same. There is my vertex. Everybody got that? One last thing I'm going to show you. Do you guys remember how to write x to the 8/5 power as a radical? We learned this at the very, very end of the year. Huh? Nope. That's a radical. What's going to go right here, everybody? 5, the bottom number. What's going to go as a power? You guys remember doing that? Okay, what about x to the 1/6 power? How would I write that? The 6th root of x to the 1st power. Got it? Well, it's not gone. We just don't write it. It's right here. Okay? Okay, do you guys remember all this? All right.